Okay, when you're solving a system of inequalities, the default word is and. It means you have to solve, it has to satisfy this condition, and at the same time it has to satisfy this condition. And when you're solving a system of and, it's the points in the intersection that work for every one of those conditions. There are systems which use the word or. So here's a system. Is it the same system or not? 4x plus 1. It is. It's the same system. The inequalities are the same. But in this case, I want to solve using the word or. So here's if you satisfy this condition, then you're in the solution set. Or if you satisfy this condition, hey, you're in the solution set. So this opens up the door to an awful lot more solutions, right? And therefore, again, we're going to have to graph it. We're going to have to show the graph in the plane. Let's just quickly graph it again, and let's see if we can nail it down. So what's it have?
Up 1.
Up 1.
And up 4 over 1.
1, 2, 3, 4, 1.
4 over 1.
1, 2, 3, 4, 1.
And it's up 5, I think.
1, 2, 3, 4, 1. Oh, 1, 2, 3, 4, 1. Good check. And this is the dotted.
Good.
Y. Okay, and then 3.
So up 3.
Yep.
And then up 2 over 1. And then up 2 over 1. Down 2 over 1. Down 2 over 1.
And this one is solid, so we can do that. Oh. Okay, can I just move that? I forget. Nope. I don't like that line. Gotta get rid of it. Redraw it, sorry. That happens. Okay, good enough. Now this one still bothers me though. This intersection, this one is a slope of 1, right? So it was gonna, I want to show that distinction, right? Those two lines are different. Okay, so now we want to be on the dotted line, above the dotted line. So all these points above the dotted line work, right? And the other way to get into the solution set is to be on or below the solid line. So these points are already included. So we would just extend these. They can go on forever, right? Because these are all on or below. On or below.
So everything works.
So does everything work?
Well, except the points on the dotted line.
Well, does this point work?
Yeah.
Yeah? Is it below the blue?
Oh, no.
Is it above the dotted?
It's in the middle of the wedge.
Ah, so it's not working, right? So this is a very strange, different solution. This time it's actually almost the reverse of this thing, right? This solution had a wedge, and it was only the points in the wedge that worked. This thing, everything is working except for the stuff in this wedge. How about that point there, where the two lines intersect?
Yeah.
It works because
it works for
it's on this line, isn't it? And if it works on one, it works. So this one works. So I'm gonna get rid of the yellow coloring. So this point does work this time, right? It is part of the solution. And this stuff does not, and this stuff does not, and anything in here. So you have to kind of draw what ultimately does work then is all this stuff here, and I'm actually, you probably pull out a marker that allows you to color and draw the attention to the fact that you're not coloring that part, right? And then that's it.
Would I be able to do that on like a test and it would count?
Yeah, it looks great, right?
Yeah.
And if you wanted to if you were, you could say in English, not this wedge part, right? That would be crystal clear as you can. You know, do your best. You're always trying to explain something, and you have to explain it in the terms that you have and what, you know, tools at your disposal. All right. So there's no way we can list all the points here. I mean, there are, you know, there are infinite set of points, and we could list a few, but we can't list the coordinates of all these points. And that's how it's very different from solving a system of equations where it was an equation and we didn't need to graph it because it really came down to just one point in the whole darn plane that worked. Here, with inequalities, it's always a set of infinite points that work, whether it's an and, where it has to satisfy both conditions, or it's an or, satisfy one condition and you're in the solution set. Okay?